Okay, so this is 2018 question 6 part B. During the long jump, Ashton has a velocity of 10.9 meters per second. Write down what we know. At an angle of 43 degrees to the horizontal when he begins his jump, he lands 1.03 seconds afterwards, and his angle was 43 degrees. We're back to degrees now, not radians, in case you're worried about that. Calculate his velocity in the horizontal direction. Okay, we're going to need a diagram. So we have Ashton, and Ashton is going up here with 10.9 meters per second, and he is making 43 degrees to the horizontal. Okay, so we're into vector analysis here. We want to know what this is. All right, so in terms of the 43 degrees, that's my adjacent. All right, so remember his velocity can be thought of being made up of a horizontal component added with a vertical component. All right, compared to 43 degrees, this is the horizontal. So looking at my SOHCAHTOA, I know the hypotenuse. So the one that uses adjacent with the hypotenuse is cos. So the cos of theta is the adjacent divided by the hypotenuse. I want to know adjacent, so that makes me rearrange it, multiply both sides by h, cos theta. So my adjacent is 10.9 multiplied by the cos of 43 degrees. 10.9 multiplied by the cos of 43. I am in degrees. Okay, so what I'm saying is the adjacent is 7.972 is probably enough meters per second. And that's smaller, that makes sense. You know, the hypotenuse would be the longest one, so the smallest one makes sense as being. So that is, let's call it VH, the horizontal velocity. The length of his jump. What do we know? We know, so it's probably one of those UVAST equations, all right? So we know his initial velocity, and we know the time it takes. Oh, that's just distance, speed, and time. That's very easy. All right, so for part 2, what are we looking for? The distance, isn't it? The length of the jump, yeah. Distance is just speed, or distance, I'm getting confused with all the letters. Let's say velocity by time, okay? Oh yeah, this makes sense. Ut plus a half at squared, but there's no a, no acceleration, so all we're interested in is s is equal to ut, grand, or vt in this case. Right, sorry, the distance is 7.97, if he's traveling 7.97 meters per second for 1.03 seconds. What does he do? Now I just used my full calculation of what the horizontal velocity was. There's no harm in doing that. I didn't use the rounded up value. I used the full one. And when I multiply that by 1.03, probably won't make too much of a difference. I got 8.21. What's that? That's a distance meters. Okay, 8.21 meters. Cool.